Imagine biting down on a steel pipe. Now imagine doing it for breakfast. That is essentially what T-Rex did every single day. And the bone didn't just crack. It shattered into powder. But here is the part that should stop you cold. None of it choked the animal, not once. A 6-ton predator was routinely crunching through the thigh bones of animals the size of school buses, swallowing the fragments and walking away perfectly fine. How? The answer involves engineering so precise that modern scientists are still piecing it together, and it starts with a force that nothing alive today can match. Today, we're going to find out exactly how much force T-Rex could actually generate, and why that number is almost impossible to believe. We will look at the jaw mechanics that let it bite through solid bone without shattering its own skull in the process. And then, the part that almost nobody stops to ask, we will figure out why swallowing crushed bone did not kill it, which turns out to involve a biological system that reframes everything you think you know about this animal. To understand what T-Rex could do, you need a baseline. A great white shark bites with roughly 4,000 pounds of force. A lion, about 1,000. A hyena, famous for crushing bones, manages around 1,100. These are all genuinely terrifying numbers, and T-Rex more than doubled all of them. Researchers have estimated its bite force at up to 8,000 pounds. That is 4 tons pressing down through a set of teeth. To put that another way, it is roughly the weight of a full-grown African elephant, being concentrated into the tip of a single tooth. But raw force alone does not explain bone crushing. The shape of the tooth matters enormously. T-Rex teeth were not blade-thin like a steak knife. They were thick, robust, and conical, almost like railroad spikes with serrated edges. When a tooth that shape drives into bone, something specific happens physically. The force does not spread out, it concentrates. Scientists have calculated that the pressure at the actual tip of a T-Rex tooth could reach up to 431,000 pounds per square inch. That is not a typo. That concentrated pressure is what initiates cracks inside the bone, and once a crack starts in a hard material, it propagates on its own. Think about safety glass on a car windshield. One small point of impact creates a web of fractures across the entire pane. Bone behaves similarly under extreme localized pressure. The T-Rex tooth did not need to slice through the bone like a knife through butter. It needed to find a fracture point and let physics do the rest. A crack would race through the internal structure of the bone, fragmenting it from the inside out. This is why paleontologists find bones at T-Rex dig sites that look almost exploded, not cut or gnawed, but shattered in a very specific mechanical way. Now, here is the engineering problem that should have stopped T-Rex cold. If your jaw is generating 8,000 pounds of force, that force does not just travel into whatever you are miting, it travels backward through your own skull. In most reptiles, that is managed through a flexible, loosely connected skull that bends and absorbs the shock. But T-Rex evolved the opposite strategy. Its skull was stiff, rigid, fused in ways that made it act more like a single solid unit than a collection of separate bones. And what kept that rigid structure from collapsing under its own force was a remarkable adaptation in the lower jaw. Researchers studying T-Rex jaw structure identified a boomerang-shaped bone bracing the lower jaw from within. This internal strut acted like a load-bearing beam in a bridge, distributing the mechanical stress of each bite across a wider area instead of letting it concentrate in one spot. The result was a jaw that could generate crushing force without the jaw itself cracking under the pressure. It is elegant in the way the best engineering always is. The solution is also the source of the power. The very structure that let T-Rex bite harder was the same structure that protected it from its own bite. The actual feeding behavior was not a single massive chomp. Researchers studying wear patterns on T-Rex teeth and on the bones it fed on identified something called a puncture and pull method. The animal would drive its teeth into a bone, twist slightly, and pull, then repeat, over and over, in localized spots. This repetitive targeted biting is what broke large bones into progressively smaller fragments. It was almost methodical, not frenzied tearing, but deliberate mechanical reduction of a skeleton into consumable pieces, which raises the obvious next question. Why go through all that effort? What was inside those bones worth the energy? Marrow. The inside of a large dinosaur bone was packed with nutrient-dense bone marrow, fat, protein, calories. In an ecosystem where food was hard-won and competition was fierce, ignoring that resource would be wasteful almost beyond comprehension. But there was something else in there too. Phosphatic mineral salts locked inside the bone matrix itself. These minerals are valuable metabolically, and for an animal the size of T-Rex, burning energy at a massive rate, having access to every possible nutrient inside a carcass was a significant survival advantage. Crushing bones was not just impressive, it was smart resource extraction. Here is where the story gets strange, and strangely intimate. We do not just theorize that T-Rex swallowed bone fragments. We have the physical proof. Preserved in the fossil record are coprolites, fossilized feces, attributed to T-Rex, and when scientists analyzed what was inside them, they found significant amounts of finely fragmented bone that had passed through the entire digestive system of this animal, which means T-Rex was not just crushing bones, it was eating them, ingesting them, digesting them, and the fragments were coming out the other side, processed. The bone pieces found inside T-Rex coprolites were not large, jagged shards. They were fine, ground down, which tells scientists two things simultaneously. First, the pulverization happening in the mouth was genuinely thorough. The puncture and pull method was reducing bones to fragments small enough to travel safely through a digestive tract. Second, and this is the part that reframes the whole picture, T-Rex had a digestive system specifically adapted to process those fragments. This was not accidental. This was a complete system, jaw to gut, all working together for one purpose. Stop and sit with that for a moment. We tend to imagine T-Rex as pure brute force, a battering ram with teeth. But what you are actually looking at is a precision system. The jaw generates force. The tooth shape concentrates it to the exact pressure needed to fracture bone. The lower jaw's internal bracing absorbs the rebound stress. The feeding behavior methodically reduces fragments to the right size. And the digestive system handles what arrives. Every single step is adapted to the same outcome. That is not a monster. That is an apex predator engineered at every level for maximum resource extraction. Hyenas are the modern world's most famous bone crushers. They have proportionally massive jaw muscles, specially reinforced molars, and a digestive system so acidic it can dissolve bone almost entirely. They are extraordinary. But even a hyena's bone crushing is limited to bones of a certain size relative to its own body. T-Rex was operating on a completely different scale, crunching through bones from animals that could weigh several tons, producing fragments and processing them cleanly. The hyena analogy helps you understand the concept, but it genuinely undersells what T-Rex had achieved. And here is the thing that genuinely surprised researchers when they modeled the skull biomechanics. The stiff skull was counterintuitive. Every other large biting animal, crocodilians, other predatory dinosaurs, large lizards, uses kinesis, meaning the skull has flexible joints that let it bend slightly and absorb bite stress. T-Rex went in the opposite direction, fusing those joints into rigidity. Initially, that seemed like it should make the skull more fragile, not less. But the modeling showed the opposite. Under the extreme forces T-Rex was generating, rigidity distributed stress more efficiently across the whole skull than flexibility would have. The engineering choice that looks wrong turns out to be exactly right. Every year, new fossil evidence refines this picture. Bite marks on bone surfaces, tooth tip wear patterns, the distribution of bone fragments at feeding sites, the coprolite record. None of these clues existed in isolation. Scientists had to read all of them together, like assembling a machine from scattered parts and reverse engineering how it ran. What emerged was a portrait of an animal whose relationship to bone was nothing like we first assumed. Bone was not an obstacle T-Rex worked around. Bone was the point. The resource everyone else left behind was exactly what T-Rex was built to reach. So why did it never choke? Because by the time bone fragments entered that throat, the system upstream had already done its job. The teeth and the puncture and pull method reduce large bones to pieces fine enough to travel safely. The digestive tract, adapted over millions of years of this exact behavior, could receive and process those fragments. There was no single dramatic moment of not choking. There was a seamlessly integrated biological pipeline that turned the largest, hardest parts of a carcass into energy. The absence of choking was not luck. It was the predictable output of a perfectly coordinated system. Those bite marks, fossilized in bone, tell one final story worth sitting with. They are not random. They show consistent placement, often at the ends of long bones, where the cortex is thinner and marrow access is easier. The animal was not attacking bone blindly. It was targeting it strategically. Some researchers studying feeding behavior have noted that T-Rex seems to have understood, in whatever way a predator understands its environment, that bone had value, and that certain approaches extracted that value more efficiently than others. Intelligence is a loaded word for an animal 66 million years gone, but purposeful behavior, the bones themselves record it. Here is where we land. T-Rex did not crush bone because it was the biggest animal and had the most force. It crushed bone and processed it safely because it was engineered from the skull down to the gut as a complete bone consumption system. The jaw architecture, the tooth geometry, the bracing structure, the feeding behavior, the digestive chemistry, each piece exists because the others exist. Remove any one element and the whole system fails. That is not brute force. That is evolution operating with a precision that took millions of years to perfect, and that we are only now beginning to fully read. Which leaves one question worth taking with you. If T-Rex was this precisely adapted for bone consumption, what else about the world's most famous predator are we still misreading, still assuming is brute force, when it might actually be precision? The fossil record keeps surprising us. Maybe the strangest thing about T-Rex is not what it could destroy, but how carefully it was built to do it. If questions like this are your kind of thing, stick around. There is a lot more strangeness buried in the natural world, waiting to be dug up. Subscribe, and I will see you in the next one.